Alright, so today is where we put all our factoring together. How do we factor any polynomial? Because, guys, when you start getting into problems, they're not going to be just all binomials together, all trinomials together, and all four terms together. So we have to be able to look at any polynomial and be able to factor it. The first step in factoring any polynomial is to always factor out the GCF if possible. Again, that's probably the biggest misstep. We always want to check for that first. So starting with this first polynomial here, which happens to be a binomial, we want to ask ourselves, does it have a greatest common factor? And yes, it does. 2 goes into 2 and 10, and then they also have an x in common. So we'd factor out that 2x in front. And remember, technically what you're doing is you're dividing each of those terms by 2x. And we would be left with x squared plus 5. Now, after we factor out the GCF, the next step is what size polynomial we're factoring. If we're factoring a binomial, we're going to look for a difference of squares. If we're factoring a trinomial, we're going to do our AC product. And if we're factoring 4 terms, we're going to go straight into grouping. So going back to this problem, since this one is a binomial, we ask ourselves, is this a difference of perfect squares? And immediately it's not, because it's not even a difference. So we are done. We do not need to say that it's prime. We just are done. We did factor it. We had a greatest common factor, and that's all we could do. All right, so the next one. What if after you look for a greatest common factor, it's a binomial and it is a difference of squares? That's always what we want to look for. If it is 2 terms, we want to look for that difference of squares pattern. So again, we always start out with greatest common factor. Do these 2 terms have a greatest common factor? And in this case, they do. If they don't, you just go to the next step. But both of these are divisible by 3, so that leaves us with x squared minus 25. All right, so then when we get to the next step, we say, is this a difference of perfect squares? Well, it is a difference, and x squared is a perfect square, and 25 is a perfect square, so we can keep factoring this. So we just let our 3 float out in front. We create our 2 sets of parentheses, one with a plus, one with a minus. We take the square root of the first term and put it in the front of each binomial. We take the square root of the last term and put it in the back of each binomial. And there we go. All right, what if it's a trinomial and the leading coefficient is not 1? So guys, if we have a trinomial and the leading coefficient is not 1, we have to do the AC product, and you're either going to have to use grouping, or some of you may have liked the box method better. Okay, so again, first step, always look for a greatest common factor. Do these 3 terms have something in common other than 1? No. The next step, what is 3 times positive 4? That is positive 12. So we are going to have to find the factors of positive 12, but they've got to add to negative 8. So if they multiply to a positive, but add to a negative, we immediately know that both of our factors have to be negative. Again, if you need to, you can always make a t-chart of all your possible factors. Negative 1, negative 12. Negative 2, negative 6. Negative 3, negative 4. And the only ones that are going to add to negative 8 is going to be that negative 2, negative 6. So, we're going to copy our first term. We're going to rewrite our middle term as 2 terms using these factors that we found. Minus 2x, minus 6x. And then we're going to copy our last term. We're going to draw a line right after the second term, but before the sign of the third term. What does 3x squared and negative 2x have in common? They have an x. So when we factor that out, we're left with 3x minus 2. Remember, if after your second group, if the sign of the third term is negative, you have to factor out a negative. If it's positive, we'll always put a positive. So what does negative 6x plus 4 have in common? Negative 2. And negative 6x divided by negative 2 is what's going to give us that positive 3x here. And positive 4 divided by negative 2 is what's going to give us that negative 2. So we take our 2 GCFs and we put them together, x minus 2. And then we put our common group beside it, 3x minus 2. All right, I also showed you in the earlier videos how you could do this by doing the backwards box method. What you would do is create a box. You would put your first term, in other words your quadratic term, in that top left corner. So we'd put 3x squared here, and we'd put our last term, that constant term, in the bottom right corner. And then when we figure out this -2 and -6, we would break up the -8x by making this one of these slanted boxes -2x and the other one a -6x. So we'd ask ourselves, what does 3x squared and -6x have in common? I'm looking at this first top row here, and we can see that that would be 3x. All right, so if you then look at the first column here, what does 3x squared and -2x have in common? It would just be x. Plus, you can check yourself. 3x times x is what gave us that 3x squared. So then when I come down here to this second row, you may think that they only have 2 in common, but remember, if that first term is negative, you got to factor out that negative. So it's going to be -2. And then you can come over here and kind of think about it. What would I have to have multiplied 3x by to get -6x? Oh, -2. Or you can look at it as, what is the greatest common factor of this second column here? And they have both are divisible by 2, but since the first term's negative, we've got to factor out the negative. And you can check yourself. -2 times -2 does give us +4. -2 times x does give us -2x. 3x times x is 3x squared, and 3x times -2 is -6x. So it's kind of like you're factoring and checking yourself, and then you could take these factors right here and put them together. One of them's 3x minus 2, and the other one's x minus 2. And remember, the order they're written in does not matter. All right, so what if we have a trinomial and the leading coefficient is 1? In that case, we can shortcut it. But remember, the first step is you always want to look for greatest common factor. So when I first look at this trinomial, my leading coefficient isn't 1, but all of these terms are divisible by 4. So I'm going to factor out the 4 in front, and then we are left with x squared minus 1x minus 2. Since the leading coefficient on the x squared term is now 1, to factor it, really all I'm doing is I'm trying to find what numbers multiplied this last term, -2, because 1 times -2 is still -2, but add to this middle term of -1. So I'm going to still do my little x game over here. They have to multiply to -2, but add to -1. Well, obviously our only factors of 2 are 1 and 2. But in order for them to add to -1, which one should be negative? Obviously, it would have to, the bigger number would have to be negative if it adds to a negative. So our factors are 1 and -2. So instead of having to do the grouping or the box, we can shortcut this. Just go ahead and create our 2 sets. What is the square root of x squared? It's just x. And then we pop our factors we found in the back. +1 minus 2. Now, if you don't like the shortcut method, you can do every single trinomial just like the problem we went over before. You never have to shortcut it. But if you want to save you some steps, anytime that leading coefficient's 1, we can shortcut it pretty quickly. Again, it's always a good idea to check them. So let's say I want to check real quick on this one. 4 times x plus 1 times x minus 2. I would leave the 4 out in front, and I want to go ahead and multiply my 2 binomials first. So first times first, x times x is x squared. Outsides, x times -2 is -2x. Insides, 1 times x is +1x. And last, 1 times -2 is -2. I would then combine like terms. So I have x squared, -2x, and +1x is -1x minus 2. And then last but not least, I would distribute my 4 back to each term. And so we would end up with 4x squared minus 4x minus 8, which is what we originally had, so we know we did it correct. Hopefully at this point you're making the connection with our polynomial, the first part of our polynomial unit where we were putting everything together, to now where we're breaking it back apart. They're just inverses of each other. All right, our very last step. What if we have 4 terms when factoring? Again, the first step is to always look for a greatest common factor. Do all 4 of these terms have something in common other than 1? No, they do not. So the next step is we want to group our terms together. So we're going to group the first two terms and the last two terms. Some teachers use parentheses. Some teachers underline them like this. I like to just put a little line in the middle because I find when you have a bunch of parentheses or underlines, it just gets confusing. So I just put a line right after that second term before the sign of the third term. All right, so what do our first two terms have in common? 3x squared. So 12x cubed divided by 3x squared is 4x, and 9x squared divided by 3x squared is minus 3. Remember, you always have to have a sign here. You got to have plus or minus. That's a mistake some students make. And whatever this sign is in front of that third term is what's going to go right here. And we must factor something out. So if we think there's nothing in common, everything has one in common. One divides into every number or term that we have. So right here, we're going to factor out that 1, and then that leaves us with that 4x minus 3. So we put our two GCFs together, 3x squared plus 1, and then we're going to put our common group beside it, 4x minus 3. And again, it's always a good idea to check it. So for this one, I'll use the box method to check real quick. So I'm going to draw my box. And on the left side, I'm going to put the terms of one of my binomials. So I'm going to put my 3x squared and my 1. On the top, I'm going to put the terms of my other binomial. And multiply back to squared times 4x is 12x cubed. 3x squared times negative 3 is negative 9x squared. 1 times 4x is 4x. And 1 times negative 3 is negative 3. And if we pull those out, none of these are like terms. So our top row is 12x cubed minus 9x squared, and our bottom row is plus 4x minus 3, and you can see we have what we originally started with.